In this video, I would like to review how to use the similar figures chart. So in this problem, I've told you that we have two similar figures. That's how you know how you need to use the similar figures chart. And I've given you two volumes and one side length. And I've asked you for the corresponding side length in the other shape. So the first thing that I would do is set up my similar figures chart. And if the similar figures chart is three-dimensional, if your shapes are 3D, you'll have 3 columns. I always set it up with 3 columns, and if you end up with a 2-dimensional figure, you don't have to fill in the last one. So in this side, we have the factor, and then the other 2 labels have to do with the describing words for the 2 items in your problem. So in this case, the adjectives are smaller and larger. If you had adjectives maybe of colors like blue and red, or maybe shape A, shape B, you can use whatever those describing words are. The key is you always want to put the one you're solving for in the middle. So I'm solving for the larger one. So I'm going to put large in the middle, and then I know the smaller one, so I'm going to put small on the bottom. And then for these 3 columns, the last column is volume, the middle column is area, and this first column is basically any type of linear unit. And this is the only one where I have to change the word also to say scale. Because when we talk about scale factor, we are in fact talking about the linear factor, not how the areas nor the volumes relate, only how the linear units relate to each other. So I'm going to go ahead and fill in my volumes. So I know that the larger volume is 648 and the smaller volume is 375. And the way this chart works is if you divide the middle column divided by the bottom column, you will get the top column. So, the row. So the middle row divided by the bottom row will always give you the top row based on how I've set this up. So I know that if I do 648 divided by 375, I get 1.73. So that's essentially what I call my volume factor. That's how the volumes relate to each other. This volume is pretty much 173% of the first volume, or it is 1.73 times larger than the smaller one. Now, in order to try to talk about the different factors, you always want to use your scale factor as kind of your base. Now, in this case, since I'm asking you a question about linear units, we only have to worry about this first column. If I had put something in this question about surface area, I would be using the middle column. So to go from the volume factor backwards to the scale factor, I just need to cube root my number. So if I take 1.73 and I cube root it, that's essentially doing this. You're going to go ahead and get 1.2. So what that means is if I have similar figures on a linear basis, they're going to have a scale factor of 1.2 when I compare their side lengths or their perimeters. But if I compare their volumes are going to compare at 1.73. So the question tells me that the smaller side length is 15, and so I just have to figure out what the larger side length is. So I can still use this little rule that the middle row divided by the bottom row gives me the top row. So I can say the middle row x divided by the bottom 15 is going to give me 1.2. And it's pretty easy to solve. Just multiply by 15 on both sides, and I would end up getting 18 for my larger side.